This series of videos are the full solutions to the free response section on the 2023 AP Calculus AB exam. Question number 1 and 2 represent the graphing calculator questions, so we will need a graphing calculator to solve these ones. Question number 1 gives a table. We have a table of our independent variable being time and our dependent variable being the F of t, which is measured in gallons per second. So it's important to note that that is a rate function. Okay, a customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by the differentiable function f, where f of t is measured in gallons per second and t in seconds since the pumping began. Select the value of t, f of t are given in the table. So we have this table, and what I've done is I've sketched out a graph here of these points. And part A of this question says, using correct units, interpret the meaning of the integral from 60 to 135 of f of t dt in the context of the problem. Use a right-Riemann sum with 3 subintervals to approximate the value of this integral. So I've drawn the 3 right-Riemann sums in this interval, so from 60 to 135. Starting at the right edge, I've drawn the right Riemann sum rectangles, and I'm going to calculate the areas of these rectangles. Okay, so the first one has a height of 0.15 from the table and a width of 30, so we end up with 4.5. Now, the units of this are going to be, since the height f of t is in gallons per second and the width is in seconds, this is going to represent 4.5 gallons. So the area underneath this rate function is going to be the number of gallons. Okay, so I'm going to write this as 4.5 G. Between 90 and 120, the width is 30 seconds, and the rate that we're going to use is going to be 0.1. So we end up with 3.0 gallons. And then the last interval has a width of 15 and a height of 0.05. So we end up with 0.75 gallons. Okay, so the sum of this integral from 0 to 135 under the f of t graph is going to be equal to 8.25, and the units of measurement are going to be in gallons. Okay, so we've got the correct units, and in the context of this problem, we understand what the units represent. It represents the total volume, and we've used a right Riemann sum to do this. Okay, so part B says there must exist a value of C for 60 to 120, where C is between 60 and 120 seconds, where f prime of C is equal to 0. Well, f prime of C equal to 0 means we have a horizontal tangent. F prime represents the derivative of the f of t function, and this means we have a horizontal tangent to that point. Well, this, first of all, since this is a differentiable function, this means that this function is smooth and continuous. And this is a necessary condition for MVT, or mean value theorem. And in this case here, this is an existence theorem, and we want to know that there exists some value of C. And that value C is going to be between 60 and 120. And if this is smooth and continuous, we can say that the average slope between of the endpoints 60 and 120 must exist in that interval. So this is what we're going to do then. We're going to say that f prime at C is going to be equal to, and again, this is because since we've established condition of mean value theorem, we're just going to find the average slope between the endpoints. So f at 120 minus f at 60 divided by that interval, is going to be 120 minus 60. That means then that the average slope is going to be equal to 0.1 minus 0.1, so there's no rise between those 2 points, and over 60. So that means that we have the f prime of c is equal to, the average slope is equal to 0. So if the average slope is equal to 0, then we know that there must exist some point c that's going to be equal to that same point, same slope, and that c must exist between those endpoints of 60 seconds and 120 seconds. So we've justified our answer based on mean value theorem. We've made sure that we've established a condition for mean value theorem. And we can see from this diagram that if we draw the average slope between these 2 points, we're going to have a slope of 0. And we know that slope of 0 must exist somewhere in between. So I've arbitrarily connected the dots using some smooth function. And we know that in between 60 and 120, there must be at least 1 point. Now, there could be more than 1 point. In this case, we could see that there could be another point down here where the slope is also 0. And there could be a second point, but the mean value theorem states that there's at least 1 point, and this will justify f prime of c equaling 0.